Welcome to Educator.com. In today's lesson, we're going to talk about writing linear functions, and in particular, we're going to discuss two forms of these functions. The first form is the slope-intercept form, and this is a very useful form of the equation because it can help you to graph a linear equation. The slope-intercept form of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Recall that the y-intercept is the point at which the graph of the equation, the point at which the line intersects the y-axis. For example, if we look at an equation in this form and it's given as y equals negative 2x plus 1, then the slope is negative 2 and the y-intercept, or b, is 1. This information alone allows me to graph the line. So before, we talked about graphing a line by finding a couple of points, and we in particular used the intercept method where we found the x-intercept and the y-intercept and graphed that. This time, I'm going to use a slightly different method. So here I have the y-intercept. This is the y-coordinate where the graph of the line is going to cross the y-axis. So that's going to be at y equals 1. X will be 0 and y is 1. Now, I also have the slope. The slope is the change in y over the change in x. And this is written as negative 2, but you can think of it in your mind as negative 2 over 1. For every 2 that y is decreased, x is increased by 1. And I'm already thinking of what I expect this graph to look like. Recall that if the slope is negative, the line is going to decrease going from left to right. It's going to go this way. If the slope is positive, the line is going to increase going from left to right. So I'm starting right here, and I'm going to decrease y by 2, 1, 2, for every increase in x by 1. So now I have another point, 1, 2, and then increase x by 1. And I now have it plenty to go ahead and graph this with. Okay. So you can see how this form of the equation is very helpful in getting information about the line and actually graphing the line. The second form of these linear equations that we're going to look at today is point-slope form. The point-slope form of the equation of a line is y minus y1 equals m times x minus x1. And you'll see that this is related to slope and the slope formula. So since the slope is y2 minus y1 over x2 minus x1, you can look and see that that's pretty familiar. Now, previously we talked about having 2 points, x1, y1, and the other x2, y2. Well, when we're working with the point-slope form, we have 1 point, x1, y1, and then the other point could be anywhere in the line. It's just another point, xy, that isn't specified. So look at how you could manipulate this to be similar to this. If I said, okay, the slope is some point on the line minus a given point over some point on the line minus a given point. Now, I'm going to multiply both sides of this by x minus x1, both sides of the equation. Okay, this cancels out, these cancel out, and that's going to give me x minus x1 times m equals y minus y1. A little bit of rearranging. I'm going to put the y portions on the left side of the equation and the x and the slope on the right side of the equation. And you see that gives me the point-slope form. And this is useful because imagine if I'm given some facts about a line and I'm told that the slope equals 4 and that this line passes through a certain point, and I'm told that it passes through the point negative 2, 6. Knowing this, I can write the equation for this line in point-slope form. So point-slope form, y minus y1 equals the slope times x minus x1. So y is any other point on this line. y1 is 6. Slope is 4. X is another x point on this line that goes along with this y coordinate, minus x1, which is negative 2. Simplifying this, a negative and a negative is a positive. What's helpful about this, so I have point slope form, is with a little bit of work, I can put this into the slope intercept form. Recall that the slope intercept form, so this is a point slope form of the equation, and slope intercept form is y equals mx plus b. So I'm going to multiply this out. This is 4x plus 8. And I want to isolate y by adding 6 to both sides. So now I have it in slope-intercept form. So this is a very useful form of the equation. And again, this can allow us to graph the equation. Parallel and perpendicular lines. First, recall that parallel lines have the same slope. So if I have two parallel lines, line 1 and line 2, and the first one has a slope of m1, the second is a slope of m2, those are equal. Perpendicular lines. The product of the slope of two perpendicular lines, the product of the slope of those is equal to negative 1. The slope-intercept form and point-slope form can be used to solve problems involving parallel and perpendicular lines. And the reason is, if I'm told that a line is parallel to another line, I have the slope. With a little bit more information, I can write the equation in slope-intercept form, or I may be given the equation in slope-intercept form and told that a line is parallel to that line. Same with perpendicular lines. By having these forms of the equation, which involve slope, and knowing the relationship between two lines and their slopes, I can write the equation for the second line, I can graph the lines, and it's all about knowing the relationships between these two lines. For example, if I'm told that the graph of a line is parallel to the line described by the equation y equals 1/2 x minus 4, and I'm also told that the line I'm looking for passes through a point 4, -3, I can graph the line I'm looking for. I can also write an equation for the line I'm looking for. So the graph of a line is parallel to the line y equals 1/2 x minus 4, and the line I'm looking for passes through a certain point. Well, since parallel lines have the same slope, and I'm looking at this and it's in slope-intercept form, which is y equals mx plus b, I now have the slope. So the slope equals 1/2. Since these lines are parallel, I also have the slope of the line I'm looking for, and it's 1/2. The line I'm looking for passes through 4, -3. So that's 4, -3, and I'm going to plot that out, 4, -3, and I have the slope. So I know that when I increase y by 1, I increase x by 2. Therefore, I can plot the line. Okay. And this is as expected because it has a positive slope, so it's increasing as it goes to the right. The same holds true for perpendicular lines. For example, if I'm told that I have the graph of a line is this stands for perpendicular, is perpendicular to the graph of the line defined by the equation y equals 1/4 x plus 6, and the line passes through some point, say 1, 2, I can graph this line. And the reason I can graph it is that I know that this slope is 1/4. And I recall that the two slopes are related by this formula. So if I'm given a point on a line as well as the knowledge and relationship between that line and a parallel or perpendicular line, I've got the point, I can find the slope, I can graph the line. Okay. First example, find the equation in slope-intercept form of the line with the slope 2/3 and passing through 2, -4. Slope-intercept form is y equals mx plus b. And I'm given slope. So I'm given m equals 2/3. So let's start from there. Y equals 2/3 x plus b. Well, in order to write this out, I also need to find b. And b is unknown. However, I am given an x value and a y value. And since I have m, x, and y, I can solve for b. So substituting in -4 for y and 2 for x. Now I can solve for b. So -4 equals 2 times 2, that's 4. So that's 4/3 plus b. Subtracting 4/3 from both sides equals b. And this is really, you could think of this as -1 and 1/3. Might be easier to look at it that way. So this is -5 and 1/3 equals b. Okay, going back to the beginning here, y equals mx plus b. So y equals, m is given as 2/3, x, and then b is -5 and 1/3. So using the facts that I was given, I'm able to write this in slope-intercept form. I was given the slope and I was given a point on the line. The point on the line and the slope, by plugging those into this equation, I could find the y-intercept, and therefore I could write this out in slope-intercept form. Example 2. Find the equation in slope-intercept form of the line passing through these 2 points. Slope-intercept form is y equals mx plus b, so I need to have the slope and I need to have the y-intercept in order to write this. The slope is the change in y over the change in x. And I'm given 2 points, so I can find the change in y over the change in x. I'm going to call this x1, y1, and this x2, y2. Okay, so m equals y2, which is -3 minus -7, over -6 minus -2. -3, and that's negative and negative becomes a positive, so +7, minus 6, a negative and a negative, that's +2. -3 plus 7 is 4. -6 plus 2 is -4. I have the slope now. The slope is -1. My next thing is to find b, which is the y-intercept. So I've got y equals mx, -1 x. We usually just write this as -x, but writing it out right now is -1x plus b. I need to solve for b. And I can do that because I have some x and y values I can substitute in. You could choose either set of coordinates, either ordered pair. I'm going to go ahead and choose this first one. So y is -7 equals negative, instead of writing -1, I'm just going to write negative times x, which is -2, plus b. solving for b. Negative 7 equals a negative, and a negative is a positive, so that's 2 plus b. Subtracting 2 from both sides, b equals negative 9. In order to write this equation, I needed to have my slope, which I do. And so I have that m equals negative 1 and b equals negative 9. So now I can go ahead and write this as y equals negative x, so that's mx, where m is negative 1, plus b, and that's negative 9. So y equals negative x minus 9. This is the equation for this line written in slope-intercept form. Example 3. Find the equation in slope-intercept form of the line passing through the point negative 2, negative 3, and parallel to the graph of y equals 3x minus 7. Slope-intercept form, y equals mx plus b. First thing I need to do is to find the slope. I am not directly given the slope. However, I'm told that this line is parallel to the line described by this equation. Parallel lines have the same slope. So if I know this slope, I know the slope for the line I'm looking for an equation of. Well, this is in slope-intercept form. Therefore, y equals mx plus b. So I have the slope. The slope of this line is 3, and the slope of the parallel line, which is my line, is also 3. So now I've got y equals 3x plus b, and in order to fully have this in slope-intercept form, I need to have b. Well, I have a point on this line, negative 2, negative 3. So I'm going to substitute in, I'm going to let x equal negative 2 and y equal negative 3, and then solve for b. Okay, so y is negative 3, x is negative 2, and I have the slope. So 3 times negative 2 plus b. That gives me negative 3. 3 times negative 2 is negative 6 plus b. Adding 6 to both sides, b equals 3. I have the slope. I have the y-intercept. I can write this out in slope-intercept form. Y equals, the slope is 3, 3x, and b is 3. Okay, so this one was a little bit more complicated than before because they didn't directly give us the slope or 2 points on the line, but what they did give us is the fact that this line is parallel to the line described by this equation. Knowing that means that I have this slope, which is 3, and since my line is parallel, it's the same slope. Once I've got the slope, I just take the point on that line, substitute that in for x and y, and solve for b. So to write it in this form, I was essentially given m. I could figure out b, and this is the equation in slope-intercept form. Find the equation in slope-intercept form of the line passing through 2, negative 1, and perpendicular to the graph of 2x minus 3y equals 6. In order to write this in slope-intercept form, y equals mx plus b, I need to have the slope of this line. I'm not given the slope directly. However, I'm told that it's perpendicular to the graph of this line. Recall that the slopes of perpendicular lines are related by this equation. So if you have the slope of two lines that are perpendicular and you take their product, it's equal to negative 1. So let's let the slope of this line equal m1. And this m2 is the slope of my line, the line I'm looking for. Let's go ahead and figure out m1. What I need to do is write this equation in slope-intercept form, and that will give me the slope of this line, which in turn will give me the slope of the line I'm looking for. First, I'm going to subtract 2x from both sides. Then I'm going to divide both sides by negative 3. That's going to give me y equals negative 2x divided by negative 3 plus 6 divided by negative 3. Simplifying, the negatives cancel out, and I'll get 2/3 x minus 2. Okay, since this is in slope-intercept form, this is m, this is a slope, so m1 equals 2/3. I now want to find m2, which is the slope of the perpendicular line, or the line that I'm looking for. m1 times m2 equals negative 1. And I'm given m1. I'm given that m1 is 2/3. So it's 2/3 times m2 equals negative 1. If I multiply both sides by 3/2, I can isolate m2, and it's negative 1 times 3/2. Therefore, the slope of the line that I'm looking for is negative 3/2. So now I've got slope. So I've got, for my line, y equals negative 3/2 x plus b. I've got slope. I need the y-intercept. Well, I'm also given a point on this line, which means I have an x and y value to substitute here. So y is negative 1. X is 2. So the 2's cancel out, and that's going to give me negative 3 plus b. I'm going to add 3 to both sides, which is going to give me b equals 2. So now I have the slope, I have the y-intercept. So I can write the equation for this line in slope-intercept form. Slope is negative 3/2. B is 2. Again, we approach this by realizing that the slope of the line we're looking for is related to the perpendicular line by the equation m1 times m2. The product of the slopes of the perpendicular line equals negative 1. So then I went about looking for the slope of this line. Rewriting it in slope-intercept form gave me y equals 2/3 x minus 2. So I know that this slope is 2/3. Once I have this slope, I can find my slope. m1 times m2 equals negative 1. So that's 2/3 times m2 equals negative 1. m2 equals negative 3/2. I go back to this form, y equals mx plus b, now knowing the slope of my line. Substitute in x and y values and the slope to solve for b. B equals 2. I have b, I have the slope. That allows me to write this equation in slope-intercept form. That concludes this lesson of Educator.com.